Welcome to Module 6, Lesson 4. Our I can statement says, I can solve multi-digit division problems using area models and the distributive property. So we're going to take what we've been practicing with area models and multiplication and apply this now to division. Number 1, Reggie shears sheep for their wool. He places all the wool in this bag. Each sheep provides 4 kilograms of wool. How many sheep does Reggie shear? Okay, so here's the bag. He has a total of 92 kilograms of wool. And we need to divide that 92 by 4 kilograms of each sheep to find how many total sheep he sheared. All right, so in order to do this, we're going to break apart 92. It already gives us a way to break up 92 into 80. What would that remaining piece be? 12. So now we've broken our dividend into 2 separate pieces, 80 and 12. Now I want you to notice how this is different than what we did when we were working with multiplication. Then we could just break it apart by place value. That was going to be an easy way for us to solve, write in an expanded form. I can't do that here. I cannot say 90 plus 2 and have this be always divisible by that divisor. Because I can't easily divide 90 by 4 and I can't easily divide 2 by 4. I'm looking for a multiple of the divisor when I break apart the dividend. So 80 was a pretty clear multiple, and 12 is also a multiple of 4. Now, when we do the area model, it's the opposite of how we did it in multiplication, right? In multiplication, we're putting our 2 factors up at the top. Well, we don't know this second factor, right? This is going to be one of our quotients here at the end. We are putting our dividends in this section, and we have 2 of them. We are dividing 80, and we are dividing 12. Now we need to think what 4 times what will equal 80, or what is 80 divided by 4? I know 8 divided by 4 is 2, so 8 tens divided by 4 will be equal to 20. And 12 divided by 4 is 3. So now let's go ahead and answer the questions. How does the area model represent the whole dividend? Okay, remember the whole dividend is 92, and the dividend broken into smaller parts, 80 plus 12. Well, if I look back at this, if you were to sit and count all the numbers of squares, there would be 92 squares in this. Each of these rectangles then has the number of squares we wrote. Has 80 squares and 12 squares. So how does it represent the whole dividend? Well, there are a total of 92 squares and smaller rectangles with 80 and 12 squares. It asks us, how does the area model represent the divisor? Okay, so 4 is our divisor. These squares are divided into these 4 rows. Right, so I can say that all the squares are divided into 4 equal rows. And then finally, how does it show the whole number quotient is equal to 20 plus 3? Well, just like we have 4 rows, we have 23 total columns, right? So the number of columns is our whole number quotient. And in this case, we happen to have 23 columns. So for letter F, 92 divided by 4 is equal to 23. So Randy shears 23 sheep. Go ahead and pause if you need more time to complete this. All right, number 2. Use an area model and the distributive property to find 217 divided by 5. Break apart 217 into numbers that are easier to divide by 7. Again, here's where I'm going to caution you to really pay attention and look for multiples. We aren't just going to take 217 and put it in expanded form. We need to find multiples. Right away, I see a multiple. I see the multiple of 7. When I look at the rest of the number, I see a multiple 21. In this case, 21 tens. So I'm going to go ahead and break this apart into 21 tens and 7 ones, or 210 plus 7. Now I'm going to plug this into the area model first, then complete the distributive property. So I know that my 2 partial dividends are 210 and 7. I can think about 210 as 21 tens. 21 divided by 7 is 3. So 21 tens divided by 7 is 3 tens. 7 divided by 7 is 1. Now let's plug it into our distributive property. 217 divided by 7 is equal to 210 plus 7 divided by 7. Each of these partial dividends must be divided by our divisor 7. So 210 divided by 7 and 7 divided by 7. 210 divided by 7 is still 30. 7 divided by 7 is still 1. We add our partial quotients to get our whole number quotient of 31. We're going to complete the first check understanding question together. If you would like to try it on your own, you may pause the video and then come back to it to check your answer. All right, AJ has 54 pounds of wool. He uses 3 pounds to make a blanket. How many blankets can he make? Use an area model to find 54 divided by 3. All right, let's look at 54. Right away, I don't see a multiple of 3. That's pretty clear to me. When I see something like this, I want to pull out a multiple that's going to be quick and easy, like a multiple of 10. I know that 54, I can pull out 30. What would be remaining if I took 30 away? Because remember, I'm looking for multiples of 3. 30 is a quick, big multiple of 3 that's in 54. Remaining would be 24. Also a multiple of 3. So I'm good to use these two numbers. All right, so I'm going to draw my area model. Right, so I know that 3 is my divisor. I'm going to divide this into equal rows of 3. And my 2 dividends are 30 and 24. Now, I'm not going to use my grid here because I don't know it yet. If you wanted to count, you totally can. You can make this a perfect area model. But right now, I'm just going to use my area model to solve. I know that 30 divided by 3 is 10. And 24 divided by 3 is 8. Therefore, AJ can make 18 blankets. All right, go ahead and pause the video to solve the next two, and then press play to check your work. All right, I went ahead and broke apart 72 into 40 and 32. I thought about it the same way I did with 54. There wasn't a clear multiple. 7 or 2 were not multiples of 4. So I went ahead and thought about a multiple of 10. When I took away that 40 from 72, I had 32 remaining, both of which were multiples of 4. So I got for my answer 18. 3, I had kind of a clearer multiple here. I had a 100 that I knew I could pull out easily and divide. So 115, my answer is 23.